Good morning everyone, my name is Amulya, roll number 620201 from section B, NIT Andhra Pradesh. Today I am going to discuss about golden section search method. First, going to introduction. Golden section search algorithm is a numerical optimization algorithm that can efficiently search a minimum or maximum of only a unimodal function. A unimodal function is a function that has single minimum or maximum point in given intervals. Golden section search algorithm uses the golden ratio to determine the interior intervals, that are search intervals. The methods work by dividing an interval into two sections, uh, with longer section to shorter section being equal to the golden ratio, that is approximately 1.618. The process is repeated until the desired accuracy is achieved. As shown in the given figure, we divide interior points such as x1, x2 in between a and b, and then we evaluate function x1 and x2 based on the interior points, and we calculate whether we need maxima or minimum. The steps involved in golden section search method. First, we need to initialize the interval a comma b and the tolerance level epsilon. Then we need to calculate two interior points c and d using the golden ratio. Here golden ratio is rho, denoted by rho, equals to 3 minus root 5 by 2, or we can use rho equals to root 5 minus 1 by 2. For calculating interior points, we need to use these two formulas. C equals to A plus rho B minus A, D equals to B minus A rho B minus rho into B minus A. Here B minus A is L0, that is the length of interval. Here we doing plus to move forward from the A, and here we using minus to move the point backwards to the B interval. After getting two interior points, then we need to evaluate functions of two interior points, and then we need to compare and set new search intervals based on whether it is maxima or minimum. If it is maximum function, then we need to discard minimization. If it is minimizing function, then we need to discard maximizing area. We need to repeat this process until b minus a means length, it should be less than epsilon. This is the uncertainty condition. Then after achieving this condition, we need to return the midpoint of final search interval as minimum or maximum. Here are the few applications of golden section search algorithm. One is in machine learning. We use for hyperparameter tuning to optimize the values of hyperparameters to maximize the performance of model. Optimization of objective function, optimize the weights or parameters of the model to minimize the loss function. Model section, search for the best model that fits the data. These are the main application in machine learning. Here are few applications in signal processing area, like filter designing to optimize the filter coefficients to meet desired specifications, and in spectral analysis for search for peak frequency or power for signal. And this is the code for optimization of golden section search. First I have taken in MATLAB. First I have taken function, sine function, and I have initialized intervals minus pi to pi. Then I have initialized tolerance. Later I have initialized the golden ratio and interior points. If condition doesn't meet the uncertainty, then we need to Then we need to initialize new intervals in between existing intervals. For that, if a function is less than f of d, then set b equals to d, else set a equals to c, then end. If for computing c and d, we use these formulas, and minimum value is the midpoint of that intervals, then we need to print minimum value. For maximizing the function, in if uncertainty condition fails, if f of c greater than f of d, set b equals to d, else a equals to c. These are the new search intervals. In these conditions, we need to print the midpoint as maximum. And I have plotted this on graph. This is my output of sine function. Minus 1.570 is the minimum and 1.57 is the maximum. This is the plotted output as here shown in legend. Function is indicated by blue and red for maximum, green for maximum, red for minimum. In conclusion, golden section search method is useful for optimization. Golden optimization algorithm for finding minimum value or maximum value of only a unimodal function. It can be work for only unimodal function, not other functions. While it has some limitations such as slow convergence of complex functions. But method is simplicity and guaranteed convergence make it a valuable tool for optimization problem, whether the function is unimodal or where the function is unimodal. Thank you.